Okay, so we've covered those precipitation reactions. Another type of reaction is an acid-base reaction, also called a neutralization reaction. Acids are substances that form hydrogen ions in solution. And we're going to treat this very superficially. There's more to acid-base chemistry than we're going to talk about, but I don't know. I just feel compelled to say that because there is so much more. But we're just going to get into it a little bit. We can recognize acids because their formulas start with hydrogen. Okay, we learned that when we talked about nomenclature. Acids have a sour taste. Lemons are very sour, right? They're acidic. They've got citric acid in them. Acids can dissolve some metals. Bases tend to form hydroxide ions in solution. The only ones we're going to look at are metal hydroxides. So things like sodium hydroxide and potassium hydroxide. Those are bases. So to recognize what is a base, it's some metal with a hydroxide ion. Bases tend to taste bitter and they feel slippery because they're actually making soap with the oils on your skin, and then if you leave them on your skin long enough, they begin to dissolve your skin, which is not really a good thing. I don't want to talk too much about that stuff because I think we come up on it later too. So here are some common acids and bases. We've learned how to name these guys. From their names, they all have acid in their names, so we should be able to recognize them as acids. Their formulas all start with hydrogen. Those guys are pretty easy. The bases, these are the common ones we'll run into, all metal hydroxides. So those are the bases. When we mix an acid and a base in water, in aqueous solution, that's when we get an acid-base reaction. And the products are always very similar. One of the products is a salt. Any ionic compound is called a salt. And I'll show you, remind me if I forget, but I'll show you a funny picture about that. That ionic compound usually remains dissolved in the solution. So here we have an example. We have an acid and a base, and we're going to have water form as one of the products, and the other product is salt. Not necessarily table salt. Here it is, table salt, sodium chloride, but any ionic compound is called salt. The net ionic equation for most acid-base reactions is the same. It's hydrogen ion from the acid and hydroxide ion from the base, and it forms water. The salt doesn't show up in this net ionic equation because it was soluble, and so it was just ions mingling around. So the pattern of this reaction is acid plus base gives water and salt. So let's write a molecular equation and a net ionic equation for the reaction between aqueous sulfuric acid and aqueous potassium hydroxide. So our reactants here, writing with the eraser just never works. H2SO4, that's aqueous, and potassium hydroxide. These compounds are soluble. They're dissolved in water. An acid, when we put it in water, forms ions. And so we can treat this for predicting products the same way we predicted the products for a precipitation reaction. We can look at what ions does this compound form. Well, this sulfuric acid forms hydrogen ions and sulfate ions, and potassium hydroxide forms potassium ions and hydroxide ions. And these are going to do that swapping thing as well. They're going to switch partners. And so we end up with potassium and sulfate and hydrogen and hydroxide. Just following that pattern we learned, where we write the guy's symbol first and the girl's symbol second. Mr. and Mrs., right? Why? Just because that's how we do it. So this is the one of the cations with the anion that it did not come with. Here's the other cation and the other anion. We just swapped partners. And now let's stick them together and see what we've got. Well, K plus and SO4, 2 minus, are going to give us K2SO4. And we'll have to figure out what that state symbol is. And then H plus and OH minus, if we're just blindly following our pattern, we're going to push them together and get HOH. And we look at that. Ho, 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 ho. That looks strange, doesn't it? What is that? That's H2O. That's water. So this is H2O. And the state of that will be a liquid. Potassium sulfate. Well, if we look it up, we'll see that it's soluble. And so, you know, we're doing our thing here, and then we're like, oh, wait, what am I supposed to be doing? Oh, I'm writing a molecular equation. Okay, so we're on track here. What do we need to do still? We need to balance it. Okay, so what do we have? Well, maybe let's leave the hydrogens and the hydroxides. Maybe we don't want to do those first. Let's look here at sulfate. Sulfate stayed intact, didn't come apart. Here we have one sulfate. There we've got one sulfate, so that's all good. And then let's look at this potassium. There's one there and there's two here. So we should put a 2 over there. Now let's check out what happened with the hydrogen ions and the hydroxide ions. From this compound, we got 2 hydroxide ions. Hydrogen ions. 2 hydrogen ions, right? H2. And over here, from our balancing of potassium, we see that we need 2 KOH molecules. That will give us 2 OHs. 2 H pluses, 2 OHs, we're going to end up with 2 water molecules. So I need a 2 in here. You can also count up all the hydrogens and oxygens separately, and you'll end up with the same thing. That's the molecular equation. Any questions? Same pattern for finding the products as with the precipitation. Just identify the individual ions, swap the partners, put them back together. The net ionic equation. Well, we kind of have stuff written out right here to help us with that. Because these are the ions that are formed by sulfuric acid. This is aqueous, this is aqueous, this is aqueous, this is a liquid. So for our in order to do the net ionic equation, we first have to have a complete ionic equation so that we can see what changes and what doesn't change. So this guy here stays together as H2O. And so we've got hydrogen ions, sulfate ions, potassium ions, hydroxide ions on the left side of the arrow. We'll just kind of draw the arrow in here. This is all pluses. And potassium ions and sulfate ions and a water molecule on the right side. What ions are not changing? Potassium's not changing. Is sulfate changing? No, sulfate's a spectator as well. So what do we have left? We have H plus and OH minus, and they form H2O. The acid-base reactions that we will encounter in this class all have the same net ionic equation. Hydrogen ion and hydroxide ion form water. Any questions?